Hi everyone, I'm sorry about the slight delay in my starting. I can't hear you at all. I've got no idea what's going on. Wave your arms at me if you can hear me. Oh, wow. Well, at least I can see that. That's brilliant. Thank you very much. You are alive. Hi, hi everyone. So I guess you know why I'm not there. So instead, I sent my hologram over. I hope this will do. It's kind of like I'm there in person, right? Except obviously I don't get to hang around with you the whole time and annoy you. I suppose that's a good thing, really. But you've got me for the next half an hour. I've got half an hour, right? Is that right, everyone? Anyone? Have I got half an hour? Yes? I'm just going to interpret a wave as yes. Yeah, how about that? Okay, good. Right, well, we're going to have quite a fun time in this half hour, I can tell you. I mean, obviously, I'm delighted that I can come and join you here at the end of JSConf. It seems like it's been a pretty amazing conference so far. Is that right? Again, wave your arms. So I'm so sorry. I just can't hear a thing at all. We're really good at technology, aren't we? Us programmers, it's brilliant. Anyway, really pleased that I could come and join you guys because I kind of feel like you are my programmer brothers and sisters. Oh, I didn't mean to go forward in my slides yet. You know, and I love sharing programming stuff with people who love programming. That's you guys, right? Yeah, I'm just going to imagine everyone's going, yeah, because I can't hear a thing. It's brilliant. But before I talk a bit about what I'm going to show you today, some creative programming, I'm going to do some live programming. It's obviously going to work flawlessly. Before I do that, I'm just going to introduce myself briefly. So this is the Creative JavaScript workshops that I've been running probably 2 or 3 years now. And it's something I love teaching because JavaScript, obviously, you all know you're the top people in JavaScript, but you've all been watching JavaScript's rise to I don't know, to stardom in the last few years. And obviously in lots of areas, but the area I'm particularly interested in is creative programming. So of course, we've got the obvious things like HTML5 canvas, like moving DOM elements around with CSS. We've got all of those things. But there's also just the fact that JavaScript is so damn fast nowadays, right? It's ridiculously fast. It's brilliant. So it opens up all of these potential avenues for creative programming. And so that's what I teach in my workshops. It's what I've been doing for years in loads of different platforms and programming languages. And now, of course, taking it all to JavaScript, it's a really fun time to be learning this type of programming built into the browser. So the workshops spun off a website called CreativeJS.com. Hopefully you've all seen it. I'm sure you subscribe and follow us on Twitter, don't you? No? All right. Yes? Okay, good. So I really wish I could hear you guys. It's fine. We live with these restrictions. It would be boring, wouldn't it, if it was too easy? Anyway, CreativeJS.com, there's a team of us that post all the fun things that we find on the internet, all the fun JavaScript stuff, you know, creative demos and tests and games, and there's also loads of tutorials on there as well. And there's this, like I said, there's a small team of us. If you were at CSSConf earlier in the week, you would have met Val Head, and she's one of the main people behind CreativeJS.com. So I'd strongly suggest you check that out if you're interested. What else? Okay, so these days I can be a digital artist. And, you know, obviously you guys are programmers, but normally when I tell people this, they think I just do Photoshop for a living. You know, obviously I don't do Photoshop. Well, I'll show you some of the things that I do. Here's a project called Lunar Trails. Now, I love this 70s game, an arcade game called Lunar Lander. So I programmed it in JavaScript and I put it in an arcade cabinet. You can see it there. That arcade cabinet is just running a full screen Chrome. I put in some physical controls so you can play the game. Now, cool part about this is that behind you, as you play, this huge plotter, this hanging V plotter, plots the trails of the path that you take in the game. Now, I don't know if you've seen the game. The idea is that you land your lunar lander on the surface of the moon. So as you move your ship, and gently try and land it on the surface of the moon, this plotter will mark the path that you took. And over time, you can see all the trails of people that have played the game build up over time. It wasn't just JavaScript, there was a processing element, and obviously the plotter itself was quite a big electronics project that's programmed with Arduino. I'm sure you guys, I think you all got Arduinos, didn't you? Is that right? Did I hear that right? Yeah, Arduinos are pretty awesome. So the plotter that I made there, along with an engineer called Paul Strotton, but the brains of that plotter is an Arduino Mega. So now you've all got Arduinos, I fully expect you guys to be able to make one of those next, right? Maybe your second or third project, maybe not your first one. Take it easy to go with, but it's great fun. I love playing with electronics. Next project I want to show you is this one called Pixel Pyros. It's a digital interactive fireworks display. The idea behind this, well, we've got this massive screen, 50 foot wide. We've got infrared cameras that pick up motion, and I'm projecting these orbs of light onto the screen, and you can see as people touch those with their hands, I'm using motion detection to see where they've moved their hands, and if I notice any motion, then it triggers a firework. This is a bit more complicated, this project. It's programmed in C++, using open frameworks. Yeah, and we just have the most massive projectors. It's absolutely ridiculous, and we're taking it on tour in the UK for the next well, between September and December this year. Really super excitingly, I'm adding lasers. So I've got to learn how to program lasers in the next few weeks. Be easy, right? How cool is lasers? Next time I present remotely, I'm going to send myself a laser version of myself. Yeah, that's pretty cool. Okay, anyway. What's next? Okay, yes, so the thing that this project, waving your arms, hi. So you guys are awesome. Right, the thing about these projects that I've shown you, and in fact, all the projects that I do, they're all designed with code. So, I mean, obviously the web design community has come up with this brilliant new idea, which is designing websites in the browser. Well, that's kind of what I do. I design all of these crazy projects in code. Sometimes I'll have an idea of what I'm trying to attempt. Other times I won't. I'll just make it up as I go along. But it's this process, this creative process that as programmers, as jobbing programmers, you might have forgotten. We all used to do this when we were a kid. We used to do little sketches and stuff. We were used to being creative, but as programmers, I think a lot of our work is like a list of checkboxes that we have to tick off one by one. I love getting back to that creativity, that iterative process, trial and error, those joyful, it's a really good fun way to program. So you probably have this message, like we're probably, like us programmers, we're probably saying to all the designers, yeah, learn to code, and we're being all snooty about it. But obviously, it's, well, I do a lot of web design conferences as well for designers, and I've been telling them to learn to code. Honestly, they've loved me telling them that. It's absolutely brilliant. It's not just all about us telling them to learn to code. We've got to be willing to meet them halfway. So I say, let's learn to get creative, because I think some of the most enjoyable work that we do is when it's this nice creative process that I've explained. So let's do some code. Yeah, live coding on a computer that's 5,000 miles away. What can possibly go wrong? It's going to be brilliant. All right, I can tell you're into this. Right, so I'm going to be using Remy's JS bin. Remy, are you there? Is Remy in? Can't see him. Is he there? No. Obviously, he's probably gone to the other talk. That's fine, whatever, Remy. We're using JS bin. If it goes wrong, we'll just blame him, shall we? All right, let's make it full screen. So I'm running this JS bin. There's a bit of HTML you can see there. It's just putting in a canvas, 400 by 400. I've also got getting a reference to that canvas. Hands up if you've done canvas programming before. Yeah, it's pretty good fun, isn't it? What we're going to do today, quite a few. Who hasn't ever done any canvas before? Yeah, a few of you? Okay. All right, well, what I want to do today is just do a little bit of graphical programming with the canvas. So let's start easy. let's draw a line. Yeah, exciting. I can tell you're excited. It's really hard to type with a slight delay. So if I make a mistake, then just wave your arms in the air until I fix it. How about that? It's going to be brilliant. It's going to be perfect. Okay, so I want to draw a line that starts at the origin and like that, and then I'm going to do a line too. Let's draw it along and down. So let's see. Now we don't see any of that line yet until we tell the canvas to stroke the path that we've just defined. There you go. It's pretty exciting. We've got a line. Yeah, I can tell you're excited about that. You guys are awesome. Right, let's make a line that instead of goes down and to the right, goes straight, say minus 70. Bit of a problem with that now. We can't see it. It's off the right of our screen. So one thing you can do with Canvas, which is pretty fun, is move the origin. Yeah, have you done this before? Yeah, a few of you? It's the entire coordinate system so that subsequent drawing actually is in a different place. So I'm going to move it 200 along, 380 down. So now when we draw our line, it's in the bottom pointing upwards. We've moved the 0, 0 point to the bottom middle of this. So what am I going to do with this? Well, it doesn't look like it, but this little line is going to become a beautiful tree. I know, it's pretty amazing, right? So of course, to draw a tree, we're going to do, we're going to do a recursive function, which I love, blows my mind. Recursive function. Right, so let's define our function. Well, I'm going to take it step by step. Let's make this a function that draws a branch, and I want to draw a branch of a particular length. I'm just going to indent my code, yeah, because I can tell you're all getting a bit disturbed about that. Yeah, program must indent. And so now, instead of just drawing a line of minus 70, I'm going to draw it minus length, right? The length of the branch that I want. And now when I call, then I can draw a branch as long as I want. 100 maybe. Oh, there's 100. Or let's stick with like 70. I'm just getting a little delay. Every time I type, it comes back a bit later. It's brilliant. All right. So here's the scary bits. Oh my God, what if at the bottom of our branch function, we make another branch? Well, obviously nothing happens. It's an infinite loop, right? It's just going to keep calling itself. The thing with recursive functions is that there has to come a time when it stops calling. So I'm going to find some condition. In this case, I'm going to make for a new branch. I'm going to make it a little bit shorter than the one I just drew. So after a while, the length of that branch will be so short that I don't want to carry on drawing more branches. So I'm going to test if the length of the branch is greater than 10, then draw a child branch. Indentation woes. Don't worry, I've got it covered. Don't worry, everyone's fine. And instead of just drawing it the next branch at 70, I'm going to draw it at length times, say, 0.8. Right, so that means that our second branch will be 80% of the length. You can see that all of our branches just stop at the bottom. So what I want to do before I draw the next branch is translate the origin onto the end of this current branch. I can do that with translate. Now, translate is always relative to wherever the origin is right now. So if I move the origin up by minus the length, then it means that when we draw the next branch, it's at the end of the first branch. Yes, look, we have a beautiful tree. Now, which way is the screen? Is it this way? Is it that way? I don't know. Which way? Never. Is it that way? Yeah. Yeah. Yeah, I don't know. I can't tell. I'm mirrored. It's very confusing. Right. So now, and in fact, just to show you what that's doing, I'm going to set the line width to be the length divided by 10. There you go. So you can see that the longer the branch length, the thicker it is. Okay. Now, obviously, a beautiful tree. What do you think? Yeah, okay, fair enough. Not yet, but it's going to get even better. I know, can you believe it? It's going to get even better. So Now these branches are all kind of a bit straight. Let's make them a bit bendy. I know, okay, so let's bend these up a bit, right. Now, as well as translating the origin, you can actually also rotate it. So I'm going to rotate the origin. Well, when you use the canvas context command, rotate, it requires an angle in radians. So if I wanted to do it, say, 10 degrees, in order to convert that to radians, I'd need to multiply it by pi over 180. I'm sure, poo, what's that? Oh, it's so hard to type from here. And so now, every time I draw a new branch, it's rotated 10 degrees to the right. I'm going to rewrite this function so that we now pass in the angle as a parameter. So I'm going to change that 10 to this new parameter. And then when we call child branches, I can pass in rotation of the next branch. There you go. Maybe I'll make it 15. A bendy branch. Okay, this is not quite what we wanted. How about at the end of every branch, we draw 2 branches? And we could do this just by copying that and pasting it and drawing. Oh, well, look at that. Whoa, that's not quite what I wanted. Minus 15. So now one branch goes right. Now, this is probably not what you expected to see, right? The problem is that we're going to go all the way down every right-hand branch until we get to the end. And then we're going to go back one to the left and then back one again to the other left-hand branch. But every time we're moving the origin to the end of the branch that we're currently messing with. So in order to fix that, well, what we can do is before we start messing with the coordinate system, we can save it. And then after we've done all of this messing around, we can actually restore it. And we have our tree. Yay. I'm imagining applause at this point. I see you all waving. So I guess that's a good sign. How am I doing for time? I think I've got 10 minutes left. So how about we make this tree grow and animate? What do you think? Yeah? All right, you guys are up for it. Let's do it. Well, the first thing we need to do if we want to make our tree grow is if we want to animate it, we'll obviously have to draw it over and over again. I'm going to do it the old school way at the moment using settings. Well, obviously you should probably use request animation frame. I'm just going to use this settings full, call it 1000 divided by 40 milliseconds every frame. That means it's going to get called 40 times a second. So now when I define this function loop, you can see here I'm translating and drawing the branch every time, but before I translate, I have to do a save and a end so that our coordinate system doesn't get too messed up. It's really hard to code from so far away. Right. So now the tree's getting drawn over and over again, but our tree, you can see it's not very interesting looking. I'll tell you what I might do just while I'm showing you this. I'm just going to call this loop function once to draw our tree once. And I want to add a bit of randomness to this. Well, I've got this random function that returns a random number between 2 numbers. So I'm going to pass in, instead of an angle of 15, I'm going to pass it a random angle between 0 and 15. And on the other side, I can pass in a random angle between 0 and minus 15. So our tree is looking a bit, well, it's a bit rubbish looking, to be honest. But let's add a bit more wideness in our angles. It's getting a bit better. But the other thing we can randomize is actually the length of the next branch. So I can make that between 0.7 and 0.9 maybe. Can't see where my cursor is. So now every branch is a random amount of the previous branch between 70 and 90%. You can see it's looking a bit more interesting looking now. Our tree is a lot more kind of beautiful looking. Might just make it a bit shorter. But the problem is that now if we want to animate this, well, we have a slight problem. In that, well, first of all, we're not clearing the screen every time, so it's just building up into a mush. But let's clear the screen every time it helps at all. So clearing the size of our canvas. So you can see that every time the tree runs, it makes a completely random tree, which, you know, is kind of a fun effect, but that's not really, if we want to make this tree grow, we're going to have to be able to draw the same tree every time, right? Which is kind of really hard and crazy. I just saw that someone told me there's 15 minutes left, but I've no idea when he said that. I think I've got 10 minutes. Is that right? Anyway, type it in. 10 minutes. Yes, good. Okay, right. So we need to figure out how to draw the same tree every time. So we need to stop this branch function being a function that just draws a random tree to being a branch object that stores the data branch. And what data does our branch have? Well, it has a length and an angle, so that's part of our property. So this wonderful, maybe slightly nasty things that you can do with JavaScript is turn a function into a class definition. Now I'm going to make a new object, which is my tree, and I'm going to make a branch, and it's going to be like 6. To be nice, I should probably put in an angle as well. I'm going to probably, well, this is where I have to do something. Now you see is actually an object. It has local variables that are scoped within here called length and angle. That's good, that's what I need. The other problem that I need for this branch is children, because now I'm going to store data for the branches. So I'm actually going to copy and paste down here that draws the branches. Oh, I'm having some problems with latency. Oh, damn it. Did that? Yeah. Is it too much? Really hard to control the mouse from so far away. Go cut and paste that up there. And here, instead of just calling branch, well, first of all, I'm going to make a variable children. I'm also going to set it as a property that is externally accessible. A bit hacky, but there we are. And now, instead of just calling branch, I'm going to add a branch object to the children. So every time I type, there's like a half-second delay before it comes back. So that's why it's not quite as slick as usual. I can't quite see what I'm typing. Gosh, live coding is hard at times. Huh? So there we are. Right, so I'm adding a new branch onto the children array. So all this stuff here, I need to put, instead of just having there as this block of code, I'm going to put it into a function called render. And obviously, I need to indent all of that stuff. Yeah, oh, yeah, I can tell you're getting nervous. Indent, for God's sake, man, indent! Right, and the only thing I'm missing the branch object that we're in, but we actually need to check to see if it's got any children. If it has, then we need for each one of those as well. So here we call I dot, this is getting worse, this latency. Oh, look, I made a mistake. Have I made any mistakes? I suppose I should probably add a semicolon. Probably see what else it's complaining about. Missing, oh, another missing semicolon. Well, I like putting my semicolons in, so I'm going to put that in. Makes me feel better. Right, so now what have we got? Well, we should hopefully have a tree. And here, instead of calling branch, well, we should probably draw our tree. I have no idea if this is going to work. Probably made some mistakes. If you notice anything, wave. Let's run it. Should we run it and see what happens? It's the same as we had before, except this time that tree is getting drawn over and over again, but in exactly the same place. So this means we can now make this tree grow, and I am running out of time. Let's do it, see how quickly I can do it. Well, I'm going to make a variable called growth. Oh, didn't spell that right. Fuzzy. You know I'm VNCing into this computer, by the way, in case you're wondering. I'm going to set the growth to 0, and then in the render function, every render, come on, scroll up, I'm going to add a little bit to the growth. Okay, growth plus equals 0.01. And here I'm going to, instead of, well, let's make a local variable called blen. Sorry about the meaningless names. I'm typing a bit too fast to give it sensible long variable names. Growth times len. So down here now, whenever I refer to length, len, I need to change it to blen. Okay, that's probably all of. So now hopefully I've done. I run it now. Hopefully it should grow. There you go. It's growing. It's growing. Oh, it's not stopping. A bit of a problem, everyone. The tree isn't stopping growing, everyone. This is pretty serious. Oh my God. Let's stop it. Oh, I'm just going to leave the background. Oh, I can see you appreciate that. Thank you. If only I could hear you, it would be brilliant. So instead of just adding 0.01 to it, well, I want it to ease towards. There's this function you can do to make it ease towards a particular position. I'm really running out of time. I don't even really have time to explain this, but I'm going to want it to ease towards 1. So now, hopefully it will stop. Is it going to do anything? Yeah, so eventually stops when it gets. Now, it doesn't look very realistic, the growth. So I'm going to, you know what I need to do? I need to store which generation we're in. This is getting crazy. And then every time I make a branch, oh my God, it's so hard to do this. I'm going to store the generation in a local variable there. And at the beginning, I need to add 1 to generation. And at the end of this branch function, I need to subtract generation. I'm really running out of time and the screen isn't updating fast enough. It's all going to shit. So now hopefully I should have a property called gen as a property inside of this object that I can use to know how far down the generations I am. Now I could use that for anything, but at the moment I'm going to use it up here to set a delay, and I'm going to set that to be gen times 10. And so now down here, instead of just adding anything to the growth, I can say if delay is greater than 0, delay minus. That's where I can make the growth. My screen isn't updated. There it is. Okay. Sorry, I would normally put that in brackets. So now hopefully the branches at the end should grow last. Now, I have absolutely run out of time, I'm afraid. But there is one here. I was going to make it sway as well, but I've just got no time. But instead, I'm going to show you this one that I made earlier, which is using exactly the system. But this has got, it grows, it also springs, and it sort of sways a bit. Look at this. Every time it does it slightly differently. And it's got a cool render style. Now, this awesome-looking robo tree was a bit of an accident, really. Didn't mean for it to look like this. I just wanted it to figure out how I could draw a branch that was fat at one end and thinner at the other end. And I got that system of circles in there. And actually, I just thought it looks loads better. Wireframe, isn't it, really? Yeah. And the normal tree. Anyway, I hope this has been interesting. I'm going to post up all of this code and tweet. Oh, look at you guys. You guys are awesome. If only I could hear you, it would be amazing. Right. So that's enough of the live coding. Now back to the final few slides in my presentation. But hopefully that's been an interesting example of the sort of discovery, these journeys of discovery that we can do. And so where next, if you want to do more of this type of thing? Well, obviously, there's CreativeJS.com. Also, there's a book called Nature of Code, which is by Dan Shippen, a really, really brilliant creative coder. He's such a good guy. Works mostly in processing, actually, so it's worth looking up processing because there's loads of resources about processing. But Dan's written a Nature of Code book, which is pay what you want, but also he's got a Vimeo channel, which is him doing all these videos of all these cool particle effects and graphics generation, generative art, and all kinds of brilliant creative coding techniques. If you wanted to come to the UK or Europe, you could maybe come along to one of my training workshops, seb.lee/training. I am really trying to figure out how I can make these available to Americans with the problem that I currently have of my visa situation, which I won't bore you with. It's fine when there's a holograms, not a problem. So, yes, maybe follow me on Twitter, Seb_Ly, and you can keep tabs with my visa application, or also if I manage to get any of my training stuff online, hopefully you'll be able to see it. Now, I'm in the incredibly fortunate position where I've been doing this creative code stuff, and obviously when you start doing this stuff, you can get paid for all personal projects. But the internet is a great place for personal projects. You put something cool on the internet, everyone tweets about it and shares it. And before you know it, you become known for doing the things that you love doing, things that you do for free in your spare time, and eventually end up doing that for a living. That's the position that I'm in now. Very fortunate to not have really any clients anymore. I just work on my digital art projects and do these conferences and workshops and stuff. But if that's something you're interested in, then you should be exploring this stuff. I'm sure you all are. You've been playing with node copters and Arduinos and all sorts, right? The last couple of days? Yeah, must have been pretty awesome. So while you're all excitable from the conference, don't give up. Go home, do some personal projects. Don't just start the personal projects, finish them. The reason people don't generally finish personal projects is because halfway through, it just becomes work, right? And it always takes 10 times longer than you thought. So my advice would be to keep your personal projects kind of small and buildable and maybe finishable, because if you don't finish a project, there's no point in even starting it. So do some personal projects, finish them, stick them on the internet. That's kind of all the time that I've got right now. I'm so sorry I couldn't be there in person. I hope this was the next best thing. I've really enjoyed showing you some creative coding techniques, and I hope that you're going to carry on. Catch me on Twitter, tell me what you've been doing, share the work you've been doing. Really love to see it. And maybe next year I'll be there in person. But until then, I'd just like to say thank you so much. It's been great to virtually meet you.